All right, hey everyone. So today, or in this video, we'll begin by uh, talking about graphing techniques. Um, Hopefully you finished the statistical error part of the last video, and now we're moving on to the graphical techniques and apply uh, some of the things that we talked about in the statistical error part of Excel, namely generating our own functions that will eventually apply in generating a list of data that will eventually graph and manipulate the plot that we create in Excel to look reasonably well for our reports. Just as again a reminder, if you're using an older version of the Excel worksheet from Blackboard, um, you can either just download it again uh, with some of the stuff already pre-filled uh, and work with that if you want, or just go into the cell again and double click inside in front of the 9.8 and just put a minus sign there in order for us to get a more realistic version of the graphs that we want to actually create in today's little lesson. All right, so once we've done that and added our minus sign in there, just press enter to exit out, and then we will begin. All right, so here you see that I have 4 columns. One is the acceleration due to gravity. There's only one we really talk about. So there's just only going to be one cell that's going to be filled with that particular value that will statically reference in our functions that we'll eventually generate. We'll then populate a list of free fall times that go in a succession of periodic intervals. I'll kind of show how to generate that for a long list of periodic intervaled sequence of numbers. Next, we'll then calculate the position of an object as a function of time, and then also the velocity of the object as this object descends in free fall under the effect of gravity on the surface of Earth. All right, so to start, you'll probably notice that I've labeled these columns already with an appropriate title. However, you'll notice that the titles, while they are appropriately suited to describe what is in the column, as well as the units that we're working in, we are unfortunately running into the problem of two things. Having too wide of columns, if we make the column wide enough to accommodate the title of the column itself, or if we have the column width to the suitable size of the numbers we're using, we're having this overlap issue of other titles in the same row as the other titles. So what we want to do, and this takes a little bit of practice, a little bit of just basically practice of working with this again and again and again, and kind of knowing certain things about Excel, doing those for quite a bit of time. So what we're going to do is we're going to add in some rows in order for us to use those empty cells in order for us to basically find a happy medium of both including the full title of the column, but also retaining a reasonable size width of the columns themselves so that they don't look ridiculously wide for all of that space. All right, so let's add those in. Just select row 3, and what we're going to do is insert a row above it into that new row. We'll do this one more time such that we get 2 empty rows underneath our titles. The next thing we're going to do is we're going to select those 3 rows in one particular column. We'll start first with the acceleration due to gravity in meters per second. And what we'll do formally to do this, what you'll need to do is select those cells. And again, we're going to go to Format Cells, which is the 4th line from the bottom in our right-click drop-down menu. Here you see that the numbers that we were working with before. We'll go to the next tab, which is the Alignment tab. And here we'll work with a few things. First, the text alignment. We'll do that in just a moment. And text control. Text control will be the most important parts of this particular part of the lesson. What we'll need to do is we'll need to merge the cells together. This will basically make these 3 small cells into one large cell. And we also want to wrap the text. Wrapping the text basically fills all the white space with as many characters as it possibly can before it gets hidden by the limits of the cell size. All right, so if we do that, we get this, and we have acceleration due to at least being shown in our 3 cells. If we widen it just a little bit, to make things not so bad, we see that we can have the entire column title being visible in these 3 cells with a very much smaller width of the column itself. Right. So one other thing that is usually aesthetically nice to do in the cells, if we go back to Format Cells by right-clicking on the merged cells, under Alignment, what we want to have done is we want the text alignment to be centered. Right? And this basically centers everything about the center line of the cell itself. You can do some center alignment of the in the vertical fashion where it is centered about a horizontal line going through the middle of the merged cell as well. However, this is usually not necessary in terms of these titles. So once we have horizontal centering done, we'll say OK, and we see that it's centered everything quite nicely within those merged 3 cells. Right. If we move on to the next title, by showing a quicker way of doing this, rather than the formal method, what we're going to do is we're going to go to Home and the drop-down taskbar. Next to where we were working with numbers in the previous video, what we're going to do is work with the alignment portion of the taskbar. And here, what we'll actually do is we'll merge and center. This will do the merging of the cells and centering horizontally the letters inside the 3 merged cells. So it does this, and unfortunately, we would then have to also wrap the text in order to make sure that the text uses, or that the text uses the entire white space available to it in the merged cells themselves. Right, so you don't have to do a centering of the text itself. The merge and center kind of does that for you automatically when you press that. The only extra thing you would have to do is just wrap text to make sure that it's just not using the very bottom of the merged cell. It's using all available space as necessary. In our case, for the time of free fall, it was particularly okay with the default width of the column itself. So no adjustment was necessary for that. Right? So if you don't have too many things to do, or let's say you were also doing some other format things, let's say you were changing, say, the font size, or whether you were bolding it or underlining it or anything like that, if you were doing extra stuff, what you can then do with that extra stuff is you can do Format Painter by selecting the cell that you want to essentially copy the format of. So in our case, we're going to copy the format of time of free fall in seconds. So if we go to our Home tab and right underneath, in the Clipboard section, we'll do Format Painter, and it should have these dashed lines that are running about the perimeter. Once we do that, click out onto the cells, just singly click, and then go to the 3 cells you want to format paint. Click, hold, and drag, and select the cells you want the format to be pasted to. All right, so we see, again, our width of the column is okay at the default settings, so we don't need to make any adjustments there. Doing that again, copy, paste in that manner, and we get this. Right. So that is how you might want to format your columns in order for it to be a bit more accessible and readable to your audience, basically the readers of your report, which would mainly be me. Making sure that your tables aren't too long such that they fall off the edge of your margins on Word, or that it just becomes somewhat ridiculous that you have large spans of white space between columns of numbers and things like that. So that just kind of keeps things nice, tight, and neat when you go to do this, in Excel and then copy your tables into Word. All right, so the next thing that we want to do is we want to generate a list or a sequence of numbers that basically have a reoccurring interval. In our case, our reoccurring interval is going to be 0.2 seconds, and we're going to want to span from 0 to about 7 seconds, so 6.8 seconds to be our final number. So naturally, one could do this the long way by typing in 0.8, 1, 1.2, 1.4, so on and so forth. However, Excel has already thought of that for us, and what we can do is we can just select the cells. Well, first what you would want to do is you want to type in the first few numbers of your sequence. Okay, so you'll have to at least do that initially, and then once you've typed in the numbers to start your sequence to give Excel an idea of what you want to happen, you then select the cells that occur. And again, with our cursor being a white cross outside of the selected cells, we go to the lower right-hand corner of those selected cells. That becomes a black cross. Once it becomes a black cross, click, hold, and start dragging, and you'll see off to the side that as you select the lower and lower cell within the column, it will kind of indicate what that final cell would be in the sequence. Okay, so we get to 6.8 seconds. Now again, we're running into that problem where the significant digit of our 0.0 is not being shown. So again, what we'll do is we'll go back to the Home tab where the drop-down menu gives us this, and we'll go to our numbers. Again, actually, you don't need to do that. You can just simply tell it to increase the decimal numbers. Sometimes it may give you more decimals than you wanted. You can always just quickly readjust that so the appropriate number of decimal places are being shown. All right, so that's how you can auto-generate a sequence of numbers. You can do this 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. I think one thing that would need to be done is just make sure that you at least have 3 numbers within the sequence. Otherwise, it assumes that you just want basically a reiteration of the cells from above. So just make sure that you provide enough information for Excel to kind of understand what the sequence is happening, and in that case. Right. So next, what we want to do is we want to calculate the position of this object by using basic kinematic equations as well as the velocity equation. So just this. And here, the basic kinematic equation that we're going to be using in one dimension for free fall of an object without any initial velocity, and starting from a position that we define as 0, we will say that the position as a function of time is 1/2 times the acceleration due to gravity times time squared. Okay. And then next, we'll then express the velocity as a function of time as the acceleration due to gravity times time. And for those of you out there that are doing calculus and want to just make sure that this comes out to be this, which is true, you can do that for yourself on your own. One thing to also notice, here I've written the fact that this equation here that I'll leave for the reader to the viewer to do as a part of their assignment is that they will need to model this particular equation as a linear trend line and make sure that they set the intercept to 0. So what we would want to do is when we generate our model of this particular equation by generating a trend line in Excel's plots, what we would want to do is make sure that the model was as accurate as possible, and make sure that since we don't have a constant in this particular equation, that constant would just essentially be 0, and so we will set and force the trend line to go through 0, even if it wants to try and do something a little bit different. All right, so what we're then going to do is we're going to then calculate the position of an object as a function of time. And so we'll start our function and we'll do 1/2. You can do this in either one of 2 ways. You can express it as a fraction, or you can express it as decimal. It doesn't matter, just so long as you're expressing 1/2 appropriately in some manner. Make sure that you explicitly multiply by g and by t squared when you create this function. So make sure you put the multiplication sign in. We'll then again reference the acceleration due to gravity. And we'll also reference the time in free fall. And that we're going to be squaring. So we'll use the caret symbol to the power of 2. Now here, if the power is simply a whole number, one doesn't necessarily have to put in parentheses, though it may be useful just to make sure that things are being done appropriately and not being merged into something else that one doesn't want to be merged with. So that's just one thing to be careful about, again, with using these symbols and stuff. Okay. Once you get that, press enter, and we get 0. That should happen as we're multiplying by 0, so naturally our initial position should be 0 as we defined it. All right. Now, if you viewed the other video, you'll know that we can copy and paste the function down. However, if we start that copy and paste of function down, where we select the cell and change our white cross to a black cross, by going to the lower left-hand corner, we see that we continually get zeros because, unfortunately, our G is changing accordingly to the row that we're copying and pasting to. So Excel doesn't necessarily know that we want to continuously reference this. It just assumes that it wants to go down the column with the rest of the rows that are being referenced in the function itself. So again, we'll have to do a static reference. So let's go to our function. You can double click inside, or you can just simply go to the function field. And in there, we're going to go to B5 and make sure that we're statically referencing B, the column letter, and 5, the row number. Again, we're locking that particular position into place, making sure that that doesn't change when we copy and paste that in the future. All right. Again, if it's 0, that means everything worked, and so long as you don't get a pop-up saying that something is wrong, you're pretty much set. Okay. And then so we'll then copy and paste like we were trying before. We see that we get numbers actually of non-zero value. All right, so you can take the time for a little bit to make sure that the significant digits are being displayed appropriately. For all intents and purposes, for us, maybe that's okay for now. That's pretty much okay for us. We could be a little bit more pedantic about it, but we won't do it for this particular exercise here. All right, for the next one, we'll be doing equals G times T. G times T. Again, the velocity at time 0 should be 0. And again, since we'll be statically referencing the acceleration due to gravity, we want to make sure it's being statically referenced by the dollar signs. So make sure that happens and press enter. And then finally, again, with your cursor being a white cross, lower right-hand corner into a black cross, click, pull, and drag until we fill out all the cells. Again, let's just kind of shore up the number of digits being displayed, and we'll just show 1 decimal like we did with the position values. All right. So these numbers are negative, indicating that effectively we have defined some point as our 0 point, and our object is falling below that. And so our measurement is relative to that point below. And what we're essentially saying is anything above that point would be a positive position. Anything below that would be negative, which makes sense as the object is falling, it's going further and further below that defined point. So this is how we would essentially have to kind of view the graphs that we're going to eventually plot. All right, so let's move on to that. What we're going to do is we're going to plot the position as a function of time, as well as the velocity as a function of time in our Excel sheet. So the first thing that you'll want to do is to make sure, for ease of doing the plotting process, is make sure that everything that you want to plot along the x-axis is to the leftmost side of your Excel sheet, and everything that you want to plot on the y-axis is to the right side of your Excel sheet. The reason why is because even when we do the special selection that we're eventually going to do, it doesn't matter the order in which you do the copying or the selecting of the columns and rows. What Excel cares about is where the placement of that column is relative to the other one. Is it more left than it is right? That sort of thing. And so it may in fact invert your plot and give you something that you didn't expect to view in the first place. So just be aware of that. If you get an inversion of what you were expecting to find, more than likely that's the issue, though this can be resolved by simply just reconfiguring the data set itself. That can be done through right-clicking on the data point and selecting the data and manipulating it in that fashion. All right, so I can show that in just a moment, as well as a means of dealing with that in case you have that issue. All right, so first we'll select our time, as we want that to be on our x-axis. And for those that are working on Macs, you'll click and hold your Command key. And for those that are working on PCs like me, you will click and hold the Control button. Click and hold that, and then what you're going to do is you're going to use your mouse and left-click and drag until you selected the next set of data. You can then, once you've done that, go to Insert. The type of chart that we're going to insert in here is always going to be a scatter plot for physics lab. Okay, without a doubt, it's going to be a scatter plot, and we're not going to put any lines associated with the dots in these graphs. So just make sure that it's a scatter plot, pure and simple in that particular manner, like such. Okay. If your columns are next to each other, they're side by side, you can always just click, hold, and drag your left mouse button, both of the columns, without having to do that hold and click and hold the Control or Command button, and also insert a chart as well, and that gives you the exact same chart that you would have otherwise done in that manner. The reason why I gave the other way to do that is because if you're separated, like in the instance of velocity as a function of time, we can't quite do this because otherwise something funny will happen when we go and insert a scatter plot. We get this. More than likely what you can always do is just delete the other one if you want to do it that manner. The more formal way of doing this is simply by doing it the way that I described initially, by first selecting your x-axis, click, hold your Control or Command button, and select the other set of cells. And then you can just simply insert the scatter plot like that. All right. So that sort of does that in that particular manner. As I said before, that will be left as an exercise for the viewer or the physics students in this particular case. All right, as I was saying before, if for some reason, say if the time and the position were inverted for whatever reason, you can always click, and I usually click on a data point to select them, and then I right-click on them on a data point to then go to drop-down menu that hopefully has this option of select data. Under this, you can then add more data sets of data that you're going to plot, or you can edit already formed ones, or you can remove these data sets out of your plot. In our case, if it was inverted, we would want to invert that, we would want to edit that particular series in our data set. So what we would then do is we would want to make sure that our X values are appropriately selected. And so we would go to this button here where it allows us to then reselect what we want. Say we want to reselect these, say as our time. Once we've done that, we press enter. And we'll do it the same for the y-axis. In this case, we'll do the time. All right, so we have here an inversion of the original graph, which was supposed to be position as a function of time. This is time as a function of position, which for us doesn't quite really make sense a whole lot. So that is just to kind of show you how you can manipulate the plot in order to change any sort of mistaken inversion of the graph itself that you didn't initially want. So that's just kind of to show that. We don't necessarily want that, so let's just say okay, okay, and then we'll just kind of undo what we did in that regards and return back to the original plot that we want to actually work with for our report. All right, so moving on from there, we'll then need to add a chart title. So just double click on chart title and then select the chart title so that it can be automatically deleted once we start typing. And we need to provide an appropriate title to the plot that we are eventually going to show in our report. And usually we want to be descriptive enough so that the reader doesn't have to guess as what's going on in the plot itself, but we don't want to be too verbose such that we're writing a novel just above our graph in our report. Normally, that would kind of be done in a caption associated with the plot itself, which would be done for more formal write-ups and things like that, more advanced things. But for all intents and purposes, for this level of physics laboratory, a sufficiently titled graph is good enough for the report. All right, so as I said before, this is the position of some object falling as a function of time. So that sounds about pretty much what we would then put in our title. So it would be a position of an object say it's a rock or something. You're dropping a rock onto to the ground or something from your hand from free fall. Just no extra velocity added, just simply drop it to the ground. So this position of an object in free fall as a function. Okay. And you can always adjust things a little bit, make things a little bit bigger, hopefully to make sure that the title kind of doesn't take up too much space, but also having just a hanging word there is also a little weird in and of itself, unless there's usually more to back it up. So 2 lines is probably well more than enough. If you're going into 3 lines, that's probably too much. 1 line of a sufficient length is definitely pretty good for a title. And so it should leave no doubt as to what is going on essentially in the experiment and what you're graphing. We're allowing some object to fall freely under the force of gravity, and we're just noting what the position is as a function of time. Okay, so that's the story behind it. Nice, sweet, short, and to the point. All right, so let's click out of that, but let's click on our graph. And we should have some new tabs available to us up here. One is design and one is format. We'll go to the design tab. And what we're going to do is we're going to add in some chart elements over here on the left. And we're going to definitely need a horizontal title axis title, and a vertical axis title. And again, these should also be appropriately labeled, usually coinciding with things being described in the title itself. So position is a sufficient axis title, and in our case, this position is measured in meters. You can write out full meters if you want to. You can do just the shortened version M in that particular case. You may need to even provide for the reader any sorts of scaling. So in the case of, say, you are, let's say this position of this object, this rock, is falling 50,000 meters, 100,000 meters, 150,000 meters, so on and so forth. And it's not explicitly 50,000, 100,000, it's just 50, 100, so on and so forth. You need to also put in that scaling there just to make sure that the reader also understands that this is not 50 meters, this is 50,000 meters, and so on and so forth. So in our case, we're doing this in hopefully a little bit more reasonable scales. Maybe we're dropping this off, say, a bridge into a river or something like that. That's about 250 meters down or something. All right. Next, the horizontal. Oops. Do that. Horizontal, and this would be naturally the time. You can do S, you can do sec, you can do seconds. Doesn't matter, just so long as, again, you have the appropriate units and everyone is in agreement that the units are what they are. All right, so this is starting to look at pretty good. Next, you'll see here, from time to time, you may have an instance in which the values for each of the axes grid marks sort of run into the graph itself. So there are a few ways that you can go about dealing with this. One such way of dealing with this is by basically clicking on one of the numbers in the axis, and then perhaps either a pop-up menu might come up or a side menu may come up. And what we will want to do is, I think axis option comes up first. Let's just hide that. I believe we want to go to labels. And here we want the label position to not be not next to the axis like this. We can place it either high, which actually does keep it near the axis, but not underneath where it will crash into our graph. Or we can place it low, where it's near actually our axis title. So in either case, for that particular instance, whichever one you're most comfortable with, or whatever you find most visually appealing, either case is fine, at least for me. Oops. So either of those two cases will be fine. So I'll just leave it high for this particular instance in this graph. All right, so we're nearly there. The one last thing that we'll need to do is we need to model this particular plot of data points that we have graphed here. Most of the reason we're going to do that is because we're always usually going to, I shouldn't say always, but usually we're going to extract a value from the trend line that we're eventually going to use in our analysis. Oh, right here is fine. All right, so what we're going to do now, let's close out of that. And then we're going to click on a data point, and then you can do this multiple ways. The way that I always do it is just click on a data point, then right-click on it, and then add a trend line. And then what will come up is hopefully a side menu or perhaps a pop-up menu. And normally what will happen is the very first things that you can choose is the trendline option. So basically what sort of form it's going to take. Usually we'll be doing linear trend lines. For this particular instance, we're actually going to be working as a polynomial. And the particular order that we're going to be working with is of order 2, since the highest power in our polynomial is t squared. Okay, so time squared is the highest power in our polynomial, so that dictates what the order of that polynomial will be. All right? So do note that you could, in fact, get better and better fits with not as perfect data by going to higher and higher orders, but just be aware that what we're trying to do is model the data set, not try and best fit the data set to something that may not necessarily be physical to us. So just be aware of sort of the model, namely the theoretical function we're trying to fit to in the end. All right, so it might either be, it will mostly be linear, but sometimes you may get something like an exponential, or you might get a polynomial from time to time. Other options that would need to be used in the graph would be more towards the bottom of this menu. And the one that we will always be using will be the display equation on the chart. Let's go back to our trend line. If you ever lose that menu, just make sure that you try and click on the trend line, and hopefully the menu will come back for you in that manner. like I said before, in our equation, we had the equation that we're trying to model, we had no constant in the position as well as the velocity. We had 0 initial velocity, and we defined the initial position to be 0. So we'll force the trend line through the intercept, or the 0 position at 0 time. However, this may not necessarily change the coefficient associated with the linear portion of the uh, polynomial of order 2 equation. So unfortunately, we can't necessarily manipulate that in so much to make that part of the trend line equation to go away. All right, so we'll just kind of have to live with it, but as we see here, we have a coefficient of 1e minus 13, which essentially means 10 to the power of minus 13 for all intents and purposes, since we're working in the area of 5. This is essentially 0 to us in the end. So that can more or less be neglected overall. Another thing that may be of interest for some people, particularly if the model that we're trying to fit against seems a bit troublesome, is that we can always display the r² value of our fit with respect to the data we're plotting. And the closer it is to 1, the better the fit. The further away from 1, the worse the fit is. And so this can kind of give you an idea as to whether or not the model that we're attempting to fit against is in fact physical, or it makes sense, it's consistent with what we have already discussed in terms of the theory behind the experiment at hand. It can also glean some light into how good the data might have been taken, how good it is in terms of the quality of data collected. Perhaps there's an anomalous reading that may have to be redone for some reason, which can happen. Just something to note. It can also help facilitate some of the discussion in the error analysis. Was the fit even a good fit? Does the derived quantity from our trend line, does the fit essentially give rise to, say, a high discrepancy when we compare the derived quantity from our trend line to the theoretical value that we eventually get? And so say if our theoretical value in this particular equation or in this experiment was the acceleration due to gravity, which is negative 9.8, we see here in our trend line that if we derived our acceleration from this coefficient in front of the x², we would have to essentially say that this coefficient is 1/2 g, which is true. 1/2 g should be negative 4.9. And so therefore, our r² being 1 allows us to say that's fairly consistent with the theoretical result that we may eventually compare to. Now, if, say, we had 6, and this r² value is maybe 0.7 or something like that, then that might be something to discuss in terms of the error analysis that would be done in the conclusion section of your report. Okay, so this is pretty much a done deal. One other thing that is also nice for the reader, particularly those that are starting to get a little older, not saying that I'm old, but it's always nice to proudly display your equation of the trend line itself. Nothing to be ashamed of. And there it is. This might be a little too large, but you can always change the font size by simply selecting the trend line label, going to the Home tab, and changing the font size under the font portion of the taskbar under Home. Okay, so 12 seems to be reasonably large for this particular graph. Okay. If you want to do any other formatting stuff, maybe bold titles and things like that, make things more snazzy or anything like that, that is entirely up to you, but this is basically minimally what I would expect to see for a good graph to be displayed within your reports that you turn in whenever we would use or create graphs in lab. Okay. So hopefully this was helpful and informative. Again, just as a reminder, I left to the viewer that you will have to make your own velocity of an object as a function of time for yourself and make it look pretty much similar to this, though it will be a linear trend line in that regards. Okay, so if you guys have any questions for me, you know my email. You should be able to contact me with that, and I'll try and email you back as soon as I possibly can. So have a good rest of your weekend, and I'll see you in class.